Hello, everyone. First of all, thank you for accepting our paper for this amazing conference. Myself, Adil Ghani, I'm a postdoctorate researcher at King Fahd University of Petroleum and Minerals in Saudi Arabia. I'm working at Intelligent Manufacturing and Robotics Research Center. Uh, Dr. Saad is my affiliate come supervisor, and this work is a joint collaboration between us. So the topic of this research is the human attack surface, detecting psychological vulnerabilities to cyber threat using the AI and social media. The reason for choosing this task or reason for this research is currently we are using, all of us are using social media in different forms, and we are both producing and consuming a lot of social media data. So there's an opportunity to use this social media as a window into the mental health so that we can help or assist those people who are having different mental health disorders. Uh, so for this purpose, we know that the problem is that the human element is the most critical attack surface in the cybersecurity. Individuals with mental health disorders are demonstrably more susceptible to social engineering attacks, phishing and digital coercion, and also the targeted exploitation as well. There has been some work that has been already being carried out, but there is a need for new approach. For this purpose, we collected the data from social media, like 7 mental health categories, plus suicidal and non-suicidal labels. We'll classify them using the different machine learning algorithms like a logistic regression, multi-naive Bayes support vector machine, and stratify them using the cosine similarity. And then the intervention was done by the Llama 2 model. I will explain in detail the methodology and all the crux of this research. First of all, the methodology. So we collected the data collection. We collected the data from the Kaggle, as I said, and using the Reddit and also the suicide data set was we get it from one of the organizations. We pre-process it. That's the most important part of any model building, because we say that garbage in and garbage out, so we have to prepare our data. For that, we use the tokenizations, lower casing, the stopword removals, contractions, spelling, and for the feature extraction, we use the TF-IDF and cosine similarity. For the classifications, we train the different machine learning algorithms, like the logistic regression, multi-normal naive Bayes, the confidence area threshold. So it was like the confidence area threshold, and also we we also trained the support vector machine, and the intervention was done by the Llama to 7 billion parameters. So what's the crux of this research? I will just explain before going into the matrices. I will explain the crux of this research. The crux of this research is to detect the people who are having different mental health disorders using the social media data, categorize them, whether they are in the anxiety, they have anxiety, they have bipolar disorder or some other mental health disorders. We do not stop here. So we then check the severity of the mental health disorder, whether it's suicidal or not. For that, so initially the data set that the initial data set we have has 7 mental health disorder classes. It was missing the normal health normal class, because the people who are not having any mental health disorder, so it was missing there. We added from the other data set, and then we use this suicidal data set. This data set has 2 classes, the suicide and the non-suicide. So we used only the suicide class and calculate the cosine similarity between the mental health disorders and the suicide class to check whether these people have who are having different mental health disorders, whether they are having some suicidal ideations or not. So we set the threshold if the cosine similarity was between the any data point and the suicide class was greater than 60, then we classify it as it's a suicidal ideation case. Like anxiety becomes suicidal anxiety, bipolar it becomes suicidal bipolar, and go and so on. Then if we find out, so this the 60% is not just a random number, so it has been backed up by the Young's index, and if the person, if we has been classified that it's having some mental health disorders, at the time we trigger the conversational chatbot backed by the LLM Llama 2 7 billion parameter, and it has been prompted to act as a some, mental health assistant, and it will the person will start chatting with it. At the same time, we are going to monitor his responses using the sentimental analyzer in the real time, whether the sentiment analysis is increasing or going into positive or the negative direction. And if after some time the mental health of this person, the sentiment score is not increasing or it's going in the negative direction, so we are going to give him some emergency response numbers. If not, then he will continue engage. We will continue engage this person with the chatbot until he wants to exit or not. So this is the main crux of this research, and we, as I said, we trained the different machine learning algorithms. The NLPAICS, it achieved 77% accuracy, the logistic regression almost 80%, and same is the case with the SVM as well. The final system with after balancing and stratification, we got about 95%, and the suicide recall for critical clinical deployments is 92%, and the AUC ROC curve for the logistic regression is 94%. If I talk about the key contributions, the key contribution of this research was is a new data set of 14 classes. It's a combination of mental health labels plus suicide risk stratification by cosine similarity. The training of different machine learning algorithms, among which the logistic regression achieved in 79.97 baseline. Final system reached about 95% after balancing and stratification. High suicide recall for clinical safety and confidence aware pipeline with Llama 2 chatbot for active intervention. And also the main important human in the loop alert mechanism and explainability module for clinicians. So the future direction would be to include the transformer-based models like BERT and ROBERT as baseline. Since here we are using only the one modality, that's text, we can go for the multimodal data, image, and other modalities, and also the cross-lingual and cross-cultural generalizability as well, and also the clinician validation with annotated ground truth, and last but not the least, the adversarial robustness and the privacy preserving deployment. The limitation of this work is that it's it's unimodal. It's using only one modality, so we can, and no Bayes baseline as well. This framework has been deployed in the Streamlit, and the link, the GitHub link, has been provided as well. Thank you for giving us the opportunity to present our work.